Welcome to a new test and teardown video. This time it's a Tenma power supply with the weird number here, 7210 yada yada yada, and obviously this is a double, triple, all-in-one super nice power supply. And believe it or not, one of my buddies came with this one a few days ago and said, hey, can you check this? Is it working? Is it gonna blow up? He found it in a dumpster. So this is a true dumpster dive power supply. Somebody obviously didn't like it anymore. So of course I think it's blown up or whatever. It's gonna probably take my fuses. So we better open and inspect a little bit first. What I did so far, I even tried to figure out this. Let's try and see if we can do this together here. A DC power supply. Okay, that's easy. I can understand that. But here's the fun thing. Okay, 0 to 30 volts. Okay, 3.3 amps, right? But then times 2. And then 5 volt, 3 amps times 1. So the 30 volts times 2 and all that is probably here, right? And then the 5 volt 3 amp, that's a fixed output, is probably that one, right? If it would have been my design, I would have written up here, this is the 5 volt, and this is the 2 times 30 over here. But it says nothing here. This is not user-friendly. It's not easy to understand, even that it is even the wrong way around. But other than that, it looks a little bit identical. We got some memories. We got some on-off output protection and something like that. Voltage, current. You probably just select if you want to change the voltage or current, and then dial, and then we can read out everything here. Perfectly fine. Yeah, let's open and inspect this thing. It's really nice and heavy. With all the screws here, it's also super stable. It looks like it was a little bit forgotten outside in the rain. And, heavy. That will be a good old transformer and some more corrosion. Inside, it looks actually quite nice and beautiful. We got 2 power supply module. They are very, very identical, with each their own fan and all that kind of stuff. And then there is another little regulator board here with an output. And I believe this transistor you see behind my finger right there. Here it is. Impossible to photo, but there is another transistor in there, and this is probably the fixed 5 volt. And I think maybe there is 2 identical 30 volts, but it's very, very confusing the way that everything here is connected. Also, because I didn't care to read the manual, I just wanted to see if I could figure out what is the main idea behind this thing. And all these boards here, they're also completely identical. See? Current sense. This is of course from the power supply that goes to the front panel. Current sense, and then output connector. But then look at that one, the red and the white connector down there. It goes to a little relay board like that, and then these wires goes over here. And I think maybe that will be the other 30 volt output from the other power supply right there. Goes here. And it goes output here. And everything is fine, right? So with this relay system here, we can either parallel or series connect those two. And the relay's controlled by this little microcontroller here at the back. And it's very secret what that is called. And we got a little bit of connectivity here, serial port, USB and all that kind of stuff. That is not mounted in this one. And again, the little readout interface chip here is also a super secret little microcontroller. And they got their own little beeper and yeah. That's more or less what I think it is on each of the power supply boards. We got those two relays, so of course it will change over the different windings depending on voltage. We got the little rectifier bridge also mounted under here on the heat sink. So I don't think it's getting really warm, but the little heat that it will dissipate is nicely fan cooled. And look at the way that the transistors here, the pins, they go through some holes and then they bend up to a little circuit board that sticks through and all that. It's a little bit weird and complex the way that they figure that out. Not the most beautiful solderings. But I don't see anything burned or blown up or anything leaked or nasty, so I think I'm just gonna plug it in and see what happens. All or nothing, right? So let's just dim the light if there's anything fascinating to see. Let's first try and turn on the mains. I can do it like this, so we can see the power consumption and all that. Nothing bad. Oh, shocking. It uses 20 watts in idle, and oh, I need to fix the video. Hang on. Let's see if this is better, this mode. Yeah. And I use some AI picture improvement features. And the thing is, with my eyes, those three readouts, they are nice and stable, but this one goes absolutely blinky flip-flops. So it looks like it's actually getting better and better. Let's try and see what happens if we so that is the output. What are we doing here? So this we can, okay, everything here is, it was definitely left out in the rain, by the way. I don't understand how to do this. It's also doing a lot of blinky flip-flops here, so it's, this part here is a little bit weird. So this is the output. It goes output and then constant voltage. I think this one is a little bit dodgy. Let's try the other one. So, okay, constant current. And then voltage and current like that. I find it really weird to understand what the heck I'm doing. I will pause the video and play a little bit more. So I have now connected 3 meters to the outputs exactly like this. So this meter is this output, this one here is the first one, and then this one is the most to the right. So this one is definitely the constant 5 volt, exactly like I imagined. And it looks like we got a lot of outputs, even though I didn't enable anything. So if I click here, output. See? I got the same. I don't hear any clickety-clackety. Maybe there's a field effect transistor or something like that. But I have the same. And it says here memory. But so some other voltage. I don't understand what I do. What do I do really? Do I click memory? I don't understand. A power supply, you don't need to be a brain surgery surgeon to figure this out. I mean, and over here it also says memory. I just want to be in normal mode. I don't want any. And then it goes clickety clackety. Okay. So I mean this one. Aha. See? And now it don't click anymore. Oh, now it clicks. Ah, so you need to do it a few times and then you get something. Okay. So voltage. Something. And then I see some other thing. But how do I get this? Do I need to, oh. And then what? This is probably the most stupid user interface. So I really need to read a manual. God damn me. No, I'm not happy at all. If I were to pick up this at my job in the laboratory and it's like this, it would just go totally in the bin. And maybe that is exactly what happened. What the heck? Because it really don't look like it's defect. It just really don't make any sense what it's doing. I can't be that dumb. I mean, really? And then I get some output. No, and then you need to do it again. Amen. Every time I turn this on and off, it's doing something different. Then I get output, and then I don't get output. When I change the different voltages, I can hear some relays, and then output disappears. So there's definitely all the relays that have something to do with voltage selections and all that, and output on off and everything more or less. None of them seems to be working, and that is definitely causing everything here to not work. And I think actually that is just it, because you can see here, first time I click here, it goes off, and then it's not going back on. Isn't that funny? But if I turn it off, then something happens with that relay, and then sometimes see 5 volt, but it says 4 volt. So there is definitely maybe this digital interface is causing all the problems. So what if I then click on and then I go off? Yeah, this is just, everything seems to be dead. But of course, it was also left outside in the rain. I mean, you can see the markings everywhere inside. That reveals that. So I have decided to try and see if I can fix this one, or at least get it a little bit better. What I've done so far, I measure from the outputs, and then I see the outputs, they are directly connected to the big fat red and black wires here, directly connected here, and directly connected to the power supply. Of course, there's a sense resistor, but that is not super important for error finding, but that is the output. And that is exactly the same with the other one, right? So the output on-off control is not done here on this board. It is the entire power supply here, or this output of this power supply, that goes on and off. So far, so good. We got those two little relays here on a little circuit board. The red and white wire, that is also this output, and it's the same on the other side. So I believe those two relays here can either parallel or series connect the two 30-volt outputs. So to isolate my little problems, I want to disconnect this connector up here and then redo my little error checking, because what if we got stuck relays here as well? And then I find the two relays here, and I believe they are the main cause of all my problems. So I want to attack first this power supply, but I want to isolate all my problems by removing this little connector and then see. So disconnecting the paralleling feature did not help in any way. So I'm taking out the entire controller board. I get all sorts of weirdo readout voltages, and it's not really copying that voltage to the power supply. So I think definitely the fault is to be found in this. What is all that with all those resistors and stuff? Is that a DA converter or whatever is going on here? Everything seems a little bit weird. But look down here. Of course, this one was left outside in the rain, and we do have some weird corrosions and stuff like that. So I want to try and take it completely apart. We got some different circuit boards and all that. So I think it's a little bit easier to see what we're doing here. Look at that. Here's a connector. Here's a connector. So this will be the readout. And that will be all the switches and stuff like that, right? And what do you know? This encoder here is the famous for being absolutely bad. Tenma uses this in all their equipment, and it always causes problems. I'll try and clean everything here. It's really a little bit, yeah, with corrosion and stuff. They try to optimize the airflow around that, and I think, yes, this is a 12-volt regulator, 7812, to handle some of this, maybe the relays or some stuff here, because this is a low voltage device. We got some other regulators here, and we got another little input with some diodes and capacitors and stuff like that. But what is causing all this leakage? So this is the left readout, and here's a really cool detail. They added black heat shrink around the LEDs so they don't shine so much on each other, and this way giving a better contrast on the different indications. I'll try and clean this a little bit. And the left readout, I believe this board is working quite all right, but remember the right one had some flippity flickering on the bottom one, and now we can see that there's a little individual latch IC that latches and handles and drives the multiplexing of that display. We got some transistors for the multiplexing and all that, and there's a little regulator to handle the little local voltages here. And we can even see it's a little bit brown, so this one also goes warm. And I think this is where we will find a problem in the other one. I can also see a little bit of leaked and nastiness here, so there's probably a drop of corrosion that is in this area on the other one. So I can try and clean that in the other one, and then it will probably work as well. But I want to take out the encoder and see if I can somehow fix that one as well. So to access the encoder, we need to take this entire switchboard out, and then I believe all these work. So I don't want to clean here or fix anything here. Oh yeah, that feels real bad. And look, it's just soldered in here. There's no additional little contact or anything there. So after the deep clean here, I think we are getting somewhere, because the encoder here works perfectly fine and stable. So all that is fine. But of course I still have a missing control from this CPU system to the power supply, and this is the output. And there's of course still this relay and all that kind of stuff that is not working. And when I enable the output, see, this is the off output, so there's a relay that is not working. So when I try and connect that relay, there's another relay that changes the voltage or select the voltage from the transformer, and that is of course not working as well. So click, click, and then I get nothing out. And then it of course measures the output voltage, and then it goes like that. So I think that is quite normal when it is not working. It's a little bit weird what it's doing here, but it's measuring the output. That is quite funny, the way that it... Yeah. They made a few pretty cool things. I mean, the rectifier bridge is supposed to be pressed down to the aluminium, but there's of course air. So the size of the rectifier here is a little bit slimmer than first anticipated, maybe. Or they just thought, well, it's probably not getting that warm after all, so a lot of splat. Splat is probably enough. They made a hole here for a screw, so there is no thread in this aluminium. At least I can't see the hole. Oh, this is another bridge, not the one intentionally designed for it at first, right? That will be the transformer windings and the relays to select the windings that goes to the capacitors. And they only mounted 2 out of 3 capacitors. I tried to look at the traces underneath here, and maybe they don't really go exactly where I think they go, but I need to take out the circuit board anyway, because I need to access those 2 relays. And here is a temperature sensor that goes into a little brass standoff, and that is a very good way to have a good thermal connection to this heatsink. And what else can I say? I don't understand exactly what is the idea with those little circuit boards like that. It's maybe because they didn't like this big board here to be a double layer, because they are more expensive. Everything here definitely yell and scream lowest possible cost. They really try to save cost anywhere they can. They use a single layer circuit board, and where it's really necessary, they of course only use a 2-layer board. So that is why they put in those little, see, and those are 2-layer boards to get this functionality. But I think I can just unscrew everything here and just pull it apart, and then I can access the relays. That's just a little driver transistor for the 2 output transistors, and there will be some emitter resistors and all that kind of stuff. Quite basic. So I was right about this rectifier. See, they put on a lot of grease, and it just barely touched in one end. There is actually a hole up here, so they could have used a screw and mounted it correctly. And the transistors, they're using self-tapping screws. And what happens when you're using self-tapping screws? Then the aluminium kind of bends up a little bit, as you can see here, and this will cause a very bad thermal connection. other than that, I will have to go and measure a little bit around here what is going on. I'm not a super fan of this particular connection like that, because you need to take it out like this anyway. But of course you want the mechanical interface here. You want to be able to mount it, screw it in, and then all the angles to be right for the transistor. So that is probably the only way to do it. They have moved themselves into a corner here with this design. I mean, they could have made it, different. See this area here? Just leave this open and then have the transistors open and then mount it on the top. Or you could also flip everything around and have the components on the other side, and this way still be able to solve this with a single layer maybe. Well, let's see what is the problem here. Oh, that is funny. Look at that. It appears the capacitors, they're just in parallel, right? Minus, minus. Ooh, positive. Really? Well, look at that. This capacitor here is directly... What? They're all parallel, right? I mean, we gotta agree on that. So that means this silk screen here says positive, where I see negative. And there's a little positive right there. Why would you do that? What the hell? I really want to take away one of those capacitors just to see if the silk screen is wrong. But that is definitely funny. In a minute I'm gonna get this splat all over my fingers. So I cleaned it a little bit, and I did a lot of measurements and experiments on this board. And you're not going to believe this, but everything here works perfectly fine. The two relays, that is how it's connected at the moment to the 4 transformer windings. And when you activate one of the relays, it simply switches the AC input to the rectifier bridge to another winding set. And you can do this here as well. Clickety click and get more or less voltage into your capacitor system. And this power supply is just emitter followers. See, the positive is that one, goes to the center pin on the 2 transistors. That will be the collectors. So here is the output connector. And this one is the positive. And the positive go to this system with emitter resistors. See those two? That will be the emitter resistors going to the emitters, surprisingly. The 2 inputs to the transistors, the base goes to that little driver transistor right there, and that one is also powered by the same voltage on its collector. And this transistor also works. It's driven by this little connector here connected to the CPU system. All this work, relay work, bridge work, capacitors work, emitter resistors work, and there's nothing that is blown up on this circuit board. It just needed a little bit of cleanup. And so now I know exactly what is the problem. The problem is, here is this cable that controls the output system, and it goes to the little microcontroller board. I've already shown close-up pictures of that, and this signal goes into the microcontroller. There's a digital or an analog output, obviously a digital to analog converter, and all that inside the microcontroller, and that one is broken on both of those boards. So this has to be some sort of like an overload or voltage feedback problem. I don't know what kind of what could cause this to blow up, but this gotta be a problem with these in general. So please, when you see this video, if you have a unit more or less the same kind of brand or the same kind of model number, I bet this controller board here is, of course, reused in many other Tenma power supplies, probably other brands as well. And you could definitely also come here and comment on this video and tell me, please, did you also have the same fault? It could be interesting to know. So, I mean, the rest of this is totally just e-waste as it is at the moment. There's nothing I can do about this, because I'm not going to reprogram a new microcontroller. I mean, this is like inventing the entire power supply once again. But I think the case is good, meter is good, everything here is nice and stable. Big, large transformer. There's a lot of good to say about this. Of course, it's really, really cheap, and yeah, it is very visible throughout the entire construction. This made as cheap as possible kind of philosophy. But anyway, I want to say thank you very much for watching, and I really need your comments, so keep them coming. And thank you very much for watching so far. Tell your friends, tell everybody about my channel, okay? Bye bye.